Good morning, everybody. How are you today? Bilal speaking. Uh, Today lecture would be about the 1200 series engine. Um, so let's talk about this engine. Giving you some general information about this engine. Let's proceed. Okay, here we go. When this engine was introduced, it covers three engine sizes. Okay, 200 kVA, 230 kVA, and 250 kVA sizes. The engine model is 1206. Six stands, of course, for the number of cylinders. A, it has to do with the exhaust emission levels. E, this means that the engine is electronic. The 70 stands for engine capacity in liters. It is 7.0 to be specific, which means the engine size is 7 liters. TT stands for turbochargers. Let me close the video to concentrate on the lecture now. Okay, so TT means that we have two turbochargers connected in series on this engine. A stands for air cooler, a radiator that will be cooling down the compressed air, which is compressed by the turbochargers. By the way, the air temperature after these two turbochargers, I mean the compressed air, its temperature is going to go as high as 250 degrees Celsius. After the air cooler, after getting cooled, it will go down to 50 degrees Celsius. Okay? G stands for generator application, which means this engine is an electropack engine type, which means it is mounted on gensets running at rated speeds, 1500 RPM. 1, 2, and 3 means modifications. That's the difference. Now, the three engines are really the same engine. The only difference would be the software on the ECM. Let's proceed. Here we go. This is a general view of the engine. Let me talk a little bit about the fuel system very briefly, because we will go into more details when we go further with the lecture. Starting point, this is the daily fuel tank, supply line. It will go through this fuel filter that we usually mount on the chassis. Okay? And then the fuel, after getting filtered, will go to an electrical fuel lift pump mounted right below the ECM. This is the ECM. This is the location of the electrical fuel lift pump. We will have another look at the electrical pump when we go further with the lecture. After the electrical fuel lift pump, the fuel will go to two fuel filters, primary and secondary. The primary one is a 10 micron type. The secondary fuel filter is a 4 micron type. Afterwards, the filtered fuel will go to the high pressure fuel pump. We will go, when we go further, we'll have a closer look at this pump and give more details. So this high pressure pump will highly compress the fuel that will go to a common fuel rail mounted here externally on the engine head side. Again, we will take another closer look at this fuel rail. From this rail, the fuel rail, fuel will be distributed to all 6 injectors. Of course, we have fuel return pipes going back to the daily fuel tank or the external tank bulk tank used by the customer. Before the fuel goes back to the daily fuel tank or to the external bulk tank, it will go through a fuel cooler to cool down the fuel relatively before going back to the fuel tank, because we are not supposed to have fuel temperatures exceeding 55 to 58 degrees Celsius, because if the fuel heats up, its burning efficiency will go down. That's why on most medium size and large size engines, we have fuel coolers. Okay, let me proceed now. Here we go. Okay, here a closer look of the high pressure fuel pump. This is the high pressure fuel pump. It is made by a company called denso. Okay. Now, can I just mount this pump without any timing marks? No, there's a timing for this pump. Okay. How we do the timing? The plug in here, you unplug this, and there's a special tool that you let it go in, you screw it in, that will lead you to get the proper timing marks. Let me show you the special tool and how this is done. Here we go. This is the special tool. Whenever you take off the plug, you screw in this probe. Okay, this probe is a spring loaded, which means when you mount it in here, screw it in, this probe will pop up from here a little bit. Okay, so you turn the engine till this popped up pin goes in. Let me show you the why this would go in. And here we go. Again, this is the plug we are talking about. This is where you are supposed to put the timing pin. And here we go. On the gear side, the base of the gear side, there's a hole. Okay, so whenever you turn the engine till the pin goes in, it means you got the proper timing mark. That's how you know. It's very easy. If you don't have this special tool, can I use a screwdriver? Yes. Why not? Yes, you can use a screwdriver. No need to buy the special tool. It is up to you guys, but you can use a screwdriver, no problem. You push in the screwdriver, you turn the engine till you feel that the screwdriver is going in a little bit by 2 or 3 millimeters. It means you got the proper timing mark on the pump. Now you can take off the pump. Okay, let's proceed now. Okay, what makes this engine a little bit different compared to any other electronic engine? At the top of this engine, we see this mixer. Okay, we call it NRS, which stands for nitrogen monoxide reduction system. So the purpose of mounting this thing, which we call NRS, we'll be going with the abbreviation NRS for this mixer, is to cut down on the nitrogen monoxide gases that will be going out from the exhaust manifold. Because, you know, nitrogen monoxide is one of the main pollutants worldwide, either from gasoline engines, cars engines, or diesel engines as well. Okay, so this is the purpose of this NRS, this mixer. How does it work? What is the idea? How can we cut down on the nitrogen monoxide amounts coming out from the exhaust system? If you look in here, we have an inlet from here, air inlet. You know, this is the pipe coming from the air cooler. Okay, after being cooled, the fresh air will get in through here. It is supposed to proceed through here, going down at the top of all the pistons, the combustion chambers. And at the same time, we have some of the exhaust gases rerouted to come through here, get in, mix with the fresh air before the mixture would go at the top of the pistons. Why are they doing this? They are cutting down on the amount of oxygen going in at the top of the pistons, so that whenever you have less oxygen, the combustion temperatures will go down. Whenever you cut down on the combustion temperatures at the top of the pistons, this will cut down on the amounts of the nitrogen monoxide that will be going out. Okay, so that's the trick. By mixing some exhaust gases with the fresh air before going at the top of the pistons. Okay, this will give you less oxygen going at the top of the pistons, which will decrease a little bit the explosion temperatures or the combustion temperatures at the top of the pistons. Whenever you cut down on the temperatures, this will cause a drop in the amounts of nitrogen monoxide emitted through the exhaust manifold. That's the trick. On cars, they use catalytic filters. Okay, this is another way to cut down on the amount of nitrogen monoxide. We'll go into more details about this mixer, the NRS, when we go further with the lecture. So let's proceed. Okay, again, this is the mixer, the NRS. If you look in here again, this is the exhaust gases inlet. This is the fresh air inlet. Okay, in here, number 9, this is an electric valve. We call it EGR, exhaust gas regulator. It is controlled by the ECM. In here we have the mechanical mechanism that is controlled by this electrical valve, which we call EGR, exhaust gas regulator. It will be this will be controlling the amount of gases that will get in to mix with the fresh air coming from here before going as a mixture, oxygen and exhaust gases at the top of the pistons. Besides, we have 3 sensors mounted on this NRS. We have one here and we have another one here. See the pipe? This pipe? Gases, exhaust gases are going through this pipe to this sensor in here, which is number 2. Okay, they call it differential pressure sensor. And there's another sensor. If you follow this hose as well, okay, it will be going to other pressure sensor, which we call inlet pressure sensor number 3. Now in between these two sensors, see, this is after the mixing exhaust gases with the oxygen. Here it is only exhaust gases coming in. Okay, so if there is a big difference in pressure reading between these two sensors, this will let the ECM give you a warning saying exhaust gas flow abnormal, which means you have clogging in here somewhere, soot clogging. Okay, so this means that you need to check and clean up this area from CO2. Okay, let me tell you something, guys. Let's talk briefly now, professionally. The very moment these engines were introduced, we really had an issue with these engines. What was the issue? Whenever load is applied on these engines after some running hours, regardless how many running hours, I'm talking about hundreds or thousands of running hours, you would find out that this engine is not taking load anymore. Whenever you go to a certain load, the engine speed will drop and the engine will shut down. If you go and check what is the fault, you will read what I have mentioned a few seconds ago. It will say abnormal exhaust gas flow, which means we have clogging here, CO2 clogging, which means you need to disconnect the NRS from here, from here, from here. This will come out as one assembly. Clean it from inside, from all 3 openings, this inlet, and this inlet. Clean it up from soot, CO2, mount it back. The engine will run again normally. After some time, again, this might get clogged as well. Okay, we had this issue at the very moment when this engine was introduced. Okay, now Perkins afterwards were aware that we have an issue here. Why are we having accumulations of CO2, soot in here? Because too much exhaust gases are getting in, mixing with the fresh air, going at the top of the pistons, causing temperature drop at the top of the pistons. Whenever you decrease the temperatures of explosions at the top of the pistons, you will cause too much CO2, carbon dioxide. So what Perkins did, they revised the flash file for the ECM so that the ECM will give orders for the EGR valve in here, the exhaust gas regulator, to minimize the amounts of exhaust gases getting in to mix with the oxygen so that the temperatures at the top of the pistons will go high again, which means you will be having less CO2. Since that moment, when they gave us this revised flash file, which we flashed to the ECMs, these engines are working normally now. We are not seeing this issue anymore. The CO2 accumulation in here. Okay, so this issue is solved. We don't have it at the moment anymore. these engines are working fine. Okay, because many people are saying that these engines are no good, they have an issue. Yes, this was the issue, and it was solved by reducing the amount of exhaust gassing getting in and mixing with the oxygen through a flash file downloaded on the ECM that is controlling the EGR, which is minimizing the amount of gases getting in to mix with the oxygen. Okay, so again, this issue is gone. We don't have this issue anymore. We rarely see NRS mixers getting clogged with CO2. Okay, okay, let's proceed now. Here we go. Okay, the timing of the engine. If you need to get piston number 1 at top dead center compression, just like the 1100 series, it is the same. If you take out the timing case cover, turn the engine on the camshaft gear, this one here, there's an opening, little tiny opening in here. This is a mark, timing mark, okay? On the body of the timing case, there's other opening as well. You need to turn the engine till these two holes match perfectly. If you got them matching perfectly, it means that piston number 1 is at top dead center compression, okay? Very close to the 1100 series engines. By the way, the bottom area of this engine, like the crankshaft, the connecting rods, are the same, just like the 1106 engine. It is almost the same engine down below. At the top, it's different, of course, because this is a revised engine and it's a 1206 electronic engine. Okay, let's proceed now. Here we go. Again, this is the NRS. A better look at the NRS. This is the electric valve, the EGR. In here, exhaust gases go in. From this side, fresh air gets in. They get mixed before going at the top of the pistons through this route. These are the two pressure valves, okay? This is the intake pressure sensor. Sorry, I said valve, it's sensors. Intake pressure sensor, and this is the differential pressure sensor, okay? This is reading the pressure before the mixing. This is reading the pressure after the mixing, oxygen and exhaust gases, okay? If any clogging in here and between these two, this differential pressure will give you this warning on the ECM, okay? Exhaust gas flow abnormal. You know that there is a clogging in here. You need to clean up this area, okay? So let's proceed now. How do we clean the NRS in case you need to clean it up? You open it up from in here. This is mount bolted, two parts, bolt mounted, okay? You take them apart. Inside, you have two reed valves. The reed valves, this is the route for the exhaust, okay? And this is the route for the air coming in. And this is the outlet. The mixture will be going out from here, going at the top of the pistons. In here, we have two mixer tubes. These might get clogged. I'm talking about just in case you have clogging inside and you need to clean it up from soot, okay? These are, you can take these out externally. Two bolts holding each one. Take them out, clean them. You open up the NRS, take it, as two parts, taking out these mounting bolts. Inside here, we'll see two reed valves. Reed valves are one-way valves to let the exhaust get in, but will not let the oxygen go the other way, okay? One-way valves. We have two of these two reed valves. So you need to clean up the reed valves, the mixer tubes, and especially the mechanical mechanism of which is driven by the electric valve, which we call EGR. That's how we make the cleaning, just in case you need to make, some cleaning. Okay, this is the mechanical mechanism of the EGR, which is driven by the EGR. Okay, the electronic or the electric regulating valve, the ERG, electronic or electric regulating valve, which is controlled by the ECM. Okay. Okay, let's proceed now. Okay, this is a real photo of the mixer tubes that we talked about. This is a real photo of the reed valves. Okay, these are the reed valves. This one is defective. You can see that these plates are gone. Okay, so this must be replaced because it will not work as a one-way valve anymore. We need these to be in here. Okay, this is okay. This is not okay. Here we go. Okay, now the mixer tubes. This is one. This is the other one. You can easily dismantle them. Two bolts. Two bolts. They will be out. You clean them. You put them back, just in case. Again, I'm not saying that we are still seeing this issue. Not anymore. But just in case you need to clean up the NRS, that's how we do it. Okay, let's proceed now. There we go. These are the turbo chargers series. They are going in series. Okay, here we go. Number one, number two, and this is the outlet for the exhaust. The fuel system. Again, this is the common fuel rail. This is the common fuel rail. From this rail, you will be seeing 6 pipes through which fuel, compressed fuel, will be going to the injectors. By the way, when you start your engine, you need a minimum of 700 plus PSI, 750 something PSI for your engine to start at cranking. Because when you crank the engine, the crankshaft RPM will be around 200, which is enough to give you a minimum of 700, 750 fuel pressure PSI to start the engine. The maximum pressure that this pump will give, the high pressure pump, would be around 29,000 PSI. Of course, this will be at full load, when the engine is running. You might get to these numbers. Here we go. This is the ECM. This ECM is of the Adam 5 type, because we have the old versions, Adam 3. We have the other version, which is Adam 4, which we have on the 2000 series, the 4000 series, the 2000 series, and the 1506 engine as well. On this engine, it is Adam 5 type. Adam stands for Advanced Diesel Electronic Management. Okay, so it is an Adam 5 type of ACMs. This is the electrical fuel lift pump, which is mounted right below the edge of the ECM. This is where the fuel lift pump is. Do we have a priming pump on this engine to prime the engine in case there's air in the fuel system and you need to bleed the air? No, there is no priming pump. How can I bleed the fuel system, the fuel filters, and the low pressure fuel system? If you click on the control panel, let's say you have a deep sea control panel on this genset, the white push button where you have a palm, printed on the white push button. You click on it, this pump will be activated for 2 minutes, okay, without having the engine running, okay? So this will be enough to bleed the fuel system if there is any air in the fuel system. That's how we do it. No need to bleed the high pressure system. I'm talking about the high pressure pump, the pipe going from the high pressure pump to the common fuel rail, and the pipes coming out, the 6 pipes coming out from the common fuel rail going to the injectors. No need. You don't have to bleed the high pressure system. By the way, when you take off any of these pipes, the 6 pipes that are going from the common fuel rail to the injectors, make sure they are not twisted or bented, because inside these pipes we have a special coating that might break down if you twist or bend these pipes. So be careful not to do this. Otherwise, you might cause damage to the pipes. Okay. Briefly, that's how the fuel system works. The starting point, we have the main fuel tank. Okay. This is the fuel filter that I showed you early at the beginning of the lecture, mounted on the chassis. Okay. This is the electrical fuel lift pump, primary fuel pump, a primary fuel filter, 10 microns type, secondary fuel filter, 4 microns type. Then we have the high pressure pump that will be pressurizing the fuel from 750 psi up to 29,000 psi. And then you have this outlet from the high pressure pump, the highly compressed fuel going to the common fuel rail. From here, fuel will be distributed to all 6 injectors through these pipes. How many return pipes we have? We have 3. One from the high pressure pump, one from the injectors, all 6 injectors, and one from the common fuel rail. Here we have a safety valve, just in case for some reason the fuel pressure exceeded 29,000 psi. This will open up, bleeding fuel back to the fuel tank. All 3 retaining pipes will go through the fuel cooler that we mentioned earlier. This is the fuel cooler. Then from the fuel cooler, fuel will go back to the fuel tank. Okay, let's proceed. Here we go. These are again the primary and secondary fuel filters, 10 microns, 4 microns. Okay, this is used as a fuel filter and fuel water fuel filter separator as well. You bleed fuel from here before you start your engine, just to be on the safe side. Some explanations that you can read when you have a copy of the lecture. Let's talk about sensors now that we have on this engine. Here we go. Now, pressure sensors. Let's start with pressure sensors. This is the inlet air manifold. We have inlet manifold pressure sensor sensing the air which is compressed and coming into the engine. We have, let's see, here we have on the common fuel rail, we have a sensor which is sensing the compressed fuel, the high pressure fuel pump, pressure. It is mounted here on the common fuel rail. We have oil pressure sensor, lubrication pump, sensor, which is mounted on the engine block right below the ECM. On the NRS, we already mentioned that we have 2 pressure sensors. Okay, the mixer, the NRS. Let's look at the temperature reading sensors. Again, on the inlet air manifold side, we have inlet manifold air temperature sensor. Okay, besides, we have another one mounted on the right after the air filter. It is not mentioned here. Right after the air filter, the pipe which is coming out from the air filter going all the way to the turbochargers. On this pipe, in between the air filter and the turbochargers, we have another, air temperature sensor as well. We have a coolant temperature sensor as well. We have 2 speed sensors, one mounted on this side. Okay, the left side, if I'm looking from the rear side of the engine, this is reading the speed of the crankshaft. And on the other side of the engine block, rear side, we have another speed sensor, secondary speed sensor, reading the speed of the camshaft. We have another type of sensors that we only have on this engine. This is the primary fuel filter. In here, down below in here, we have a water in fuel sensor. If there is any water in the fuel primary fuel filter, this sensor will be sensing the presence of water in the fuel. Likewise, for the auxiliary fuel filter, which is mounted in the chassis as well, we have WIF sensor, water and fuel sensor. It will be sensing the presence of water in the fuel if there is any. Okay, this will not cause a shutdown by ECM. It will only give you a warning, no shutdown. Okay, the shutdowns will be only related to overspeed, low oil pressure, and high coolant temperature. Okay, let's proceed now. Okay, top view of the engine. This is the NRS. As mentioned earlier, we have two pressure sensors, okay, plus another sensor mounted here from the exhaust, the inlet side. It will be sensing the exhaust temperature. Okay, these are the speed sensors, okay? One in here and one from the other side. And we have an atmospheric pressure sensor. This is the one. Where is the location of this atmospheric pressure sensor? It is mounted right behind the ECM, okay? This is the base where the ECM is located. Right behind it in here, this one, open to the ambient, to the ambient atmosphere. It is sensing the atmospheric pressure, okay? This is the one. Okay, not that much. Okay, oil. Let's talk about the oil a little bit. We are using CI4 type. Okay, do not use CH4 or CG4. Go with CI4 as a minimum. You can go to CK4. It's not available really in the markets. So go with CI4. We change oil every 250 running hours because in our countries, third world countries, we have an issue with the fuel quality, high sulfur contents, contaminations, chemicals, dirt, water. So we replace oil, change oil with filters every 250 running hours. By the way, this engine is a 12-volt system, one battery. Okay? Make sure that the battery size should be a minimum of 150 amps. Do not use smaller batteries. Go with 150 amps as a minimum. This is the exhaust cooler, which is mounted right behind the turbochargers. What is the purpose of this cooler? Whenever some of these gases that we were talking about will be going to the NRS, it must be cooled down a little bit. It will go in here. It is water cooled in here. Engine, you are using engine coolant to cool down relatively the exhaust gas temperatures before coming out from here, going to the NRS. This is the schematic. Air system, air filter, the first turbocharger, second turbocharger, the air cooler. Okay, this is the NRS before the air gets at the top of all six pistons. From the exhaust side, here we go. The exhaust coming out from here. Most of the exhaust gases will go through the turbochargers, through the muffler to the outside. Some will be going to the cooler. This is the cooler that I just spoke about to cool down the temperatures of the exhaust gases before getting to the NRS, mixing with the fresh air, getting in at the top of the pistons. The 7 is the EGR valve, the ERG valve, exhaust regulating gas valve. Okay. Okay. Let's proceed. This is 34. Here we go. The injectors, very simple. Okay. We have a solenoid at the top of these injectors controlled by the ECM. Whenever they receive a 70 volts DC signal from the ECM, these injectors will spray fuel. Let's see how they work. Here we go. This is the injector, how it works. If the solenoid is not energized, highly pressurized fuel will get at the top of this plunger and at the bottom of this plunger. Both pressures will equalize each other, which means this plunger will not be lifted up, so that we'll be having the fuel sprayed. Second step, whenever the solenoid is energized, 70 volts DC, look what's going to happen. This puppet will be pushed or pulled up by the magnetic field created by this coil. Okay, so the incoming pressurized fuel still going in here and at the same time going here at the top. But now this exert pressure here will be leaking out through this opening from the injector all the way back to the fuel tank. Okay, so now what you have is high pressure in here. Okay, this will lift up. This is spring loaded plunger, all 6 openings here at the top. at the tip of the injector will be exposed, and you'll be have a fuel spraying. Okay, whenever the solenoid is de-energized, this opening will be clogged again. Again, the pressure coming in will go in here and in here, equalizing each other, and no more spraying. That's how these injectors work. Okay. At the top of the pistons of the injector, sorry, you have this code, okay, which is called injector's E-trim flash file code. Okay, if you need the file, you need to get to Perkins website to get the flash file that you should be downloading on the ECM whenever you replace an injector. For example, if you replace this injector, put another injector, it will be having a different eTrim flash file code. So you need to go to the website, Perkins website. You need a password, of course, to get in. You get the file and download it on the ECM for that replaced injector. Let's say it is injector number 1. So go to the ECM software and download the new flash file code instead of the previous one. That's how it works. Turbochargers, we are talking about this. We do not have to adjust the valve lashes of the valves on this engine. Why? Because this system or this engine has hydraulic tappets, just like cars. No need to adjust the valves on these engines. By the way, guys, let me give you a hint concerning whenever a fault is generated on the ECM for some reason, low oil pressure, high coolant temperature, whatever. You need the software, the EST, Electronic Service Tool software on your laptop, licensed, and the connecting tool to get in connection with the ECM to read the fault. Let me tell you something, guys. You can get what is the fault on the ECM without having the tool, the software or the hardware connecting tool, the EST tool. How? You go to the deep sea panel, okay? If it's of the advanced type, you go to the ECU section. You can read the what is the fault. They will give it like this: SPN, a number. They call it SPN, suspect parameter number. Let's say it is 72. The number is 72. You can go to Google, okay, internet, download the list of SPNs. It has a lot of numbers, okay? So you go and check what is SPN 72. It will give you a description. Besides the SPN, you will read as well FMI, failure mode indicator or index, okay? This again found on the same list. I can give it to you, no problem. I have it, okay? But you can download it from Google. Failure mode indication or index, it gives you again detailed description of what is the fault, so you would know what is wrong, why you have a shutdown or a warning on the ECM. Okay, so you can skip using EST software to know what is the fault by reading the SPN and FMI from the deep sea panel. Okay, but you need the list for the SPN and FMI, the description based on the number of the SPN or FMI to know what is the description. I can give it to you, no problem. Okay, if you need it, get in touch with our office in Dubai. I will send it to them and they can give it to you, no problem. Basically, this is what I would cover for today. Thank you very much for joining this lecture. Thank you very much.